So today's conference is going to be about Gentoo, as you can see here. So it's hosted by our school, which I'll introduce later, and our student technical associations, which are here. So that's our aerospace association, our robotics association, and our computer science association. So here we go. So yeah, as an introduction, who am I? I'm a student here at ESIEA, which is the greatest school of engineering in France, here in Paris, which is kind of specialized in embedded systems and information systems. I'm a computer science enthusiast, among other things, which would be music, physics, mathematics, and lots of other things. So why am I here? Obviously because I like Gentoo, and I'm kind of a wizard. So here's the thing. When I first came here, I actually started talking to people down with the technical associations, and when they finally found out I was running Gentoo, I was kind of considered like some kind of wizard. I don't really know, but well, actually they kind of left all due respect when they realized I was running Chromium, but that's another thing. And I was asked, I don't remember who asked that, but I was asked, how do I install packages? And I was like, well, I'm just running a command and pressing yes to install packages. That simple, actually. And so it kind of prompted me the idea to do this conference to actually show that it's not this complicated to actually use Gentoo and do something with it, install it, etc. So that's what I'm going to be doing after that. So as a bit of a trivia thing here, Gentoo is actually a species of penguin, the fastest species of penguin on Earth, actually. So the penguin would be Tux, the Lionet's mascot. And so yeah, I guess we'll see if it lives up to its name. So yeah, the first part is going to be introducing Gentoo in a few words, so its philosophy, etc. Then the core part of Gentoo, which is Portage, which is its package manager. So that's very important. And then a little bit of review on the compile everything approach. So as you'll see later, on Gentoo you basically compile every package, most packages actually. And then a conclusion. So Gentoo's philosophy is mostly about freedom. That's what you're going to find on the wiki and on many IRC channels when you're going to go there, which would be not forcing stuff down the user throat. So as an example, some distributions actually force you to use some init systems, specific init systems. Well, on Gentoo you don't have to do that. You can use both init systems, which would be so OpenRC and systemd are supported. So no problem here. And yeah, most importantly, the choice that would be that the user actually can do whatever he wants in terms of packages, in terms of configuration. And so that goes through some features, which I'll explain later. Use flags, slots, use flags, which are pretty notorious in the Gentoo environment. And you can even install multiple kernels, which are all officially supported, so you don't have problems installing, for example, a hardened kernel for servers, for example. And so, yeah, the great pro of Gentoo, basically, which is advertised a lot, is its optimization, its speed. So the diverse options you have in terms of customization allow you to actually provide for better speed, better optimized system, basically. So yeah, that thing I was talking about earlier, the compile everything approach, is just a consequence of all that, actually. So here we go. So yeah, I'm going to talk about Portage now. So this is the package manager of Gentoo. So that's really the core part of Gentoo. It's really the most important thing in Gentoo. So the way it works basically is that, like most distributions, you have actually have what they call portage tree, sorry, which references every package under different categories. So which you can see here. These are only some of them. This is pretty long actually. And within all of these categories, you have different packages, and so yeah, this portage tree is kind of a repository that would be the repository you're syncing every time you actually sync the package database. And so the main package unit, if I can say so, is what we call an e-build. So basically it's kind of a recipe to actually how you're going to install the package, how you're going to compile it. So basically, where to retrieve the files, the sources you're going to compile, how you're going to compile them, sorry, and where you're going to install them. So that's really the atom, actually, kind of the atom of Gentoo package, and many more features which I'll introduce later again. So yeah, the most important feature in Portage is the use flags. So let's begin with a case study. Let's say I want to install FHE. So I'm just running this command. So the eval arguments. These actually you're going to use them pretty much every time you're going to do something with Portage. So ask to actually make sure you can watch what you're doing and say yes or no. So just don't screw up your system in a single command. And the verbose part is to well, basically give you all the information you need about what you're going to do with this command. And in this case, since I didn't really want to install the patch on the computer, I was just adding the pretend command. So basically, it just shows us what's going to happen when you run if you run the command for real, but it doesn't actually do it. So as you can see here, you've got variables here, which are called use. So that's the principle of the use flag. Basically, every package comes with most packages actually come with configure scripts, which you're going to use to adapt the package to the software, the piece of software to your system, and basically tell it what you want to include in a package you're going to install, or what you don't want to include. As an example, okay, if I don't want to compile SSL support for Apache, I can just disable it, and well, I'm going to have Apache installed without SSL support. That's not a very relevant example, but you can do this, for example, for packages which actually which you can use graphically. But let's say, for example, you don't run a system which has a graphical user interface. Well, you don't need to compile support for X or GTK or Qt, and you can just make it all CLI command line interface. So that's a great advantage of Portage, because it basically allows you to be really flexible and to really select all the features you need and not more. Unlike other distributions, which where you don't have that configuring part, and basically you install everything every time, and that results in packages being heavy in your system, and well, that's kind of the so yeah, these are basically standardized compilation options, because these configure scripts I was talking about earlier, they're mostly package specific, which means the keywords that are being used to configure every package are specific to each package. For example, some package you want to compile it for GTK, you're going to have to say you want to compile it for GTK, and the one you're going to have to say GTK for. And so basically the biggest interest of all this is to say that you have common keywords for your whole system, and you can customize it along general rules you fix yourself. So there are two types of use flags. Global use flags, which well, you can edit in this file here. So that's basically the main file of the main configuration file of Portage. And so yeah, these, as I said, are kind of general guidelines which your system is going to follow when it's going to install packages. So for example, let's take the example I had earlier. Let's say you don't run a graphical user interface. Well, if you say -x in the use flags, for example, so you want to disable the X flag, support for X in the packages. Well, every package you're going to install will not have X support, so that's something nice to install, and that's kind of great, I think. And there are local use flags which you would edit on a package-by-package basis. So the idea is to kind of make exceptions regarding the general use flags you defined earlier. So let's say, for example, you need support for specific library or specific pieces of software. For one package, when you can set the exception here, but not just script your whole system with this package support for all the other packages. And there are many more configuration options. So C flags are the flags you actually use, you pass along to the compiler because, as I said, most packages are compiled on Gentoo. And so the compiler really plays a central part in the distribution. And so C flags, for example, -OS or -O2 to optimize. So these are the flags you're going to pass along to the compiler for every package you're going to install, so they're pretty important. Make-ups is kind of the same thing. For example, if you want to compile, one that comes to mind is the -J flag, so it's the number of concurrent compilation process you're going to run at the same time. So in some cases, the rule is to have like, I think one more process than you have than the core number of your CPU. But you might want to edit that to actually adapt in terms of memory use, etc. CPU flags, so that's also important in terms of optimization because every CPU has a different instruction set. The instructions is somewhat mostly common, but you've got specific instructions, notably in SIMD, single instruction multiple data, yes. Instruction sets like AVX or SSE, you can set that up so that it only compiles support for the flags that your CPU uses, but not instructions that your CPU doesn't actually use. So, and video cards. So video cards are always specific subject in the Linux ecosystem. So yeah, basically the idea here is to specify what kind of video card you have on your computer. And then again, only compile support when it's needed. So not compile support for AMD cards when you're running NVIDIA, for example. Package keywords. So that's, I'll come back to it later, but that's really important in terms of stability for Gentoo as a distribution. Since basically you're going to be able to, tell it whether or not you, you've got actually keywords for each package. Keyword is going to be, for example, whether or not this package is considered stable or not, and so yeah, the idea is to limit the user in terms of, give him a warning if the package is going to install is not considered stable for its current version. And so yeah, that's the idea of package keywords. Basically, if you accept a keyword for a given package, you're going to accept that this package is not really not been thoroughly tested, and perhaps it is unstable. So yeah, the idea is to kind of protect the user, but still leaving him the choice to actually opt in for to install an unstable package. And the list goes on and on and on because the configuration options are pretty large. There's tons of them. And so that's my make.conf. That's the file I was talking to you about earlier. That's basically the central part of configuration files of Portage. So as you can see here, the C flags I was talking about. So the architecture of the CPU, O2 and pipe. CXX flags, which basically inherits the flags from the flags you're going to use with the C compiler to use them with the C++ compiler. The use flags I was talking about. So I'm not using no, obviously I'm XFCE. Not using KDE, Qt, CUPS, and I'm using ELSA and XFCE. So basically these are general rules your packages are going to be compiled against. So this is the makeup option. So J5 means you're going to run 5 jobs concurrently in terms of compilation. I don't actually have a video card, so that's the integrated graphics of the CPU. And so yeah, as you can see, there's many options which you can set. Features no strip, for example, is to use Valgrind, which is debugging software for C. You actually have to use this so that Valgrind can actually see what's happening in your memory. So that's an option. So another great feature of Portage is slots. So the idea is to be able to install multiple versions of one package concurrently and being able to run them somewhat flawlessly. So it's a native feature. So an example that comes to mind is GDK or PHP, for example. You've got, I mean, recently you've had, somewhat recently, a few years now, but you've had an update of PHP 7, but some servers are still running PHP 5, and some applications have never been updated for PHP 7. So you might, as a server administrator, keep support for both applications. And so slotting allows you to do that because it allows you to run concurrently PHP 7, PHP 5. So that also works with GTK, so GTK 2 and 3. Linux kernels, so there the idea is that maybe you don't have, you want to keep for now a kernel that's currently running, but you want to work on configuring a new version of the kernel, so you can keep both at the same time. So you've also got many tools to help with portage because it's kind of not obscure, but it's somewhat complex, and you need tools to actually help you. Let's say searching for a package for given keywords in a package description. So Q and Get Toolkit are the major tools you're going to be using. So Q is basically a C translation, if I could say so, of the utils you have in Get Toolkit. So, well, with these tools you can do basically anything with portage. You can search for packages, you can search for dependencies, you can resolve dependencies. That's pretty complete. To configure the system, so you've got GCC config, which is then again an util which allows you to most of the time select most of the time you're going to upgrade GCC, for example, and you're going to want to select a given version of GCC. And so GCC config allows you to do that natively because, well, compiler is such a central piece of Gentoo. You've got eSelect and profiles in general, so that's more of a feature. And so the idea behind profiles is to have a set of general configuration rules which are going to suit to a given usage of your computer. So as you can see, again, the list is way bigger actually, but let's say you want a system which is specialized for a given, I don't know, Windows Manager, KDE or GNOME, whatever. Well, these profiles are going to come with a huge list of use flags which are really detailed, so that you don't have to actually set all the use flags you're gonna want to use, but you don't know about. And so yeah, eSelect is a tool that allows you to use this profile feature and select the configuration set you actually want to use. In terms of preventive maintenance, you've got an util that's called RevDev Prebuild. So basically the idea here is to, in the case that, for example, an update screws up with the libraries you have, which are shared with other packages, you want to check that out and you want to fix it, because updating a package and screwing up others is not really great. And so it allows you to do that. It allows you to check every binary against the libraries it's supposed to be compiled with, and make sure everything is in place. GLSA check. So GLSA is Gentoo Linux security advisories. So that's mostly useful for system administrators. The idea here is that when there is a security concern that's being raised and fixed with a new package version, if the problem is important, so it's a vulnerability on a package like Apache or an important package, well, there's going to be an advisory that's going to be published by Gentoo, and so this util is going to help you actually check the versions of your packages and see if basically everything is up to date in terms of security. So let's say you want to run for some reason an older version of PHP. There's really no reason to do that, but the idea is that it allows you to check if there's a problem in terms of security or not with this. And so eSelect needs read, that's more a comment, but that's the mechanism that allows package maintainers to actually publish information when they update packages. So, for example, let's say in terms of configuration, something has changed in the package. Well, the package maintainer can share on that so that the user can adapt accordingly. And so, for example, when support for a given form of configuration is dropped, the user is going to be able to read that and to adapt to this so that he's not caught off guard when doing the next update. And sandboxing, so that's pretty great. That's basically when as long as your package, when your package is being compiled, it's being compiled in a sandbox, and only when the package is done being compiled, it's going to be moved to the actual system, so that if something fails in the compilation process, you don't end up with half the binary files on your system and half absent, so that will kind of break the system. So yeah, that prevents that. Another great feature, yeah, there's lots of them. Feature of Portage is overlays. So basically, these are community-operated repositories. They're implemented natively. That's kind of the middle ground between the community repositories in the more common distributions like Debian or Gentoo, and the AUR for Arch. The idea is that basically it's going to allow you to how can I put it? It's going to allow you to actually create custom overlays, which, for example, let's say you want to fork a given package, make modifications to it, and actually upgrade it at the same time you upgrade your whole system. If you want to do this, you can do this. Sorry, with overlays. Mostly it's used when a community wants to maintain a set of packages that's not supported officially. So if I recall correctly, packages like specifically computer science security, like not sure if Nmap is supported officially, but let's say it's not. The idea is that you can maintain a set of packages which aren't really supported officially, and still update them at the same time you're updating your whole system. So that's pretty powerful, I think. So yeah, that's what it looks like. So that's the repo configuration file of Portage. So here I'm specifying the default repository, so the official repository. But you can also specify different repositories which are going to be updated at the same time as you're going to update your whole system. So for example, I'm doing a bit of Arduino programming. There's a repo called crossdev AVR. Well, the idea is that I'm going to be able to get all the packages related to AVR compiling through this. This also happens when you have custom workarounds in terms of device drivers, which aren't really implemented yet in the official tree, because the changes have not been vetted, they're too recent, and so you can maintain, someone can maintain these changes, and you can actually incorporate them to the package management system instead of having to install them manually and basically screwing with the other packages, because they're not going to know these packages are here. So yeah, the great feature of Portage is the package sets. So the idea is to select package sets. For example, when I'm making an update, I'm gonna update all the packages, and to say I'm gonna update all the packages, I'm gonna use @word. So it's prefixed by @. This world set is actually all the packages you wanted to install, so you manually wanted to install them. So that means you're going to be able to rebuild, for example, your whole system just based on this set. So that's a file actually. The idea is that you don't include the packages which are required by dependencies or anything like this. So it's really just the packages you wanted to install yourself, not the dependencies. And so another great thing with Gentoo is that you can actually back up the whole system, just saving your user data and /etc, so all the config files, and this specific file. So in practice, that's a bit of a case study. So that's how you're going to update your system most of the time. You're gonna, it's supposed to be a double dash here. You're gonna sync the Gentoo tree, the Pôle tree, sorry. You're gonna run the update, so U for update, D for deep, I think. N is new use, so basically you're gonna update, if you change your use flags, for example, you're gonna want to update this in terms of the packages which are installed. So let's say, for example, you install a package that's got a use flag, and that use flag triggers dependencies, and you remove that use flag, you're going to want to uninstall the dependencies because they no longer needed. And so the new use does this, and A is ask, as I said earlier. And at world is the set of packages I was talking about. So you're going to update the packages you really wanted to install, and then the dependencies are going to follow. And then clean the use dependencies, so that clean AV, that's very simple. And check the libs consistencies, because sometimes it happens that package update screws with other libraries. And so yeah, you want to repair that. And then it's done, or perhaps not actually. Gentoo is a rolling release system, so that means well, that means there's no proper distribution updates, official updates. You're gonna update it on the run as packages, as different packages are being updated at different rates. And so specifically for GCC, the compiler, you're gonna have to switch profiles when the compiler switches version. So when you go from GCC 7 to GCC 8, you're gonna have to do that because you want to compile with the most recent compiler, especially when there's security vulnerabilities. So yeah, now let's talk about the compile everything approach, as I call it. So that's the main problem of Gentoo, really. It's that not everyone has a beast of a computer, and compiling packages, especially when there's 300 of them, is kind of resource intensive. The way I see it is that it's a trade-off between runtime performance and practicality when you're gonna upgrade your whole system. Basically, the extra time you're going to spend compiling packages is time you're going to spare in terms of performance when you're going to run the packages. So in terms of optimization, well, as I said earlier, there's this CPU-specific instruction sets that you're going to be able to select individually. The compiler options, which I talked about. So that's for example, let's say you want to compile for an embedded system, for example, and you're constrained in terms of space you have on the device. Maybe you want to optimize for size, which is in the default option when you compile most packages. And you're going to be able to use it to run at atypical hardware, so pretty old architectures or stuff that's not supported normally. Another great thing I think with this compile everything approach is security, because a few years ago some sites have been compromised. So basically the websites where you would normally download the packages have been compromised, and the archives have been replaced, the checksums have been replaced, which would lead to users knowingly downloading so-called updates, but really they're just backdoored packages. And so pulling straight from the repositories kind of avoids that, sorry, because it's downloading from most of the times the master branch on GitHub, for example. And in order to commit changes to the main branch, you're going to have multiple developers agreeing on it, and so it's way harder to actually knowingly push backdoors from there. Sources are sometimes smaller than binaries and more efficient, and again, compression is more efficient than sources, because some packages sometimes like to compile with the binaries, lots of libraries too, but inside the package. So using the source, downloading the sources is going to be great for this. if you're actually using this, if you're actually running it on trying to set up embedded environments, you're going to use different architectures, somewhat atypical sometimes, like AVR with Arduino or ARM, etc. The great thing with Portage is it's so focused on compiling is that it has native toolchain management, which means you can switch between toolchains, compile for ARM, compile for x86 or x64 bits. And it's kind of easy to set up a cross-compiling environment. So that would be running your system with GCC to compile your own packages in your own architecture, but also being able to compile in ARM for different systems, embedded systems you're working on. So yeah, Arduino. And so the main problem I was talking about earlier, the performance cost. There's two ways mostly to mitigate it. This to see, so that's the idea here is to distribute compilation of the network to computers that are normally more capable to handle the load. So let's say you're running a laptop, you don't necessarily want to compile your whole thing on the laptop because it's gonna warm up a lot, and that's not great. And so yeah, it makes the idea of a cache server really interesting because your server is at the same time going to download the packages and going to compile them, so that it kind of saves you the effort of compiling them on your own PC. And it's really great when you have multiple computers on Gentoo. You can just pull the pre-compiled binaries, but you compile them yourself, so it's great. Also especially useful for embedded systems, because you obviously don't want to compile 300 packages on Raspberry Pi, for example. And it can handle multiple compiling hosts. So let's say you have multiple calculators in your network and you want to spread the load on these different hosts. Well, you can do that with this to see, so that's great. And bin this, so that's a use flag. And the idea here is that it means binary distribution, so it's basically downgrading Portage to a more regular form of package manager, which would be downloading our pre-compiled binaries. So that's mostly useful for navigators, browsers, which are really heavy to performance intensive to compile. But yeah, it kind of defeats the entire purpose of the arguments I was making earlier about compiling your own packages being great. And so yeah, as a conclusion, still Gentoo. It's really not that complicated. As I said earlier, the package managing system is really not that hard to handle. It's very powerful and it's very stable. I've had servers running for I think 800 days for now, which I had to update periodically, and well, I've got no problem with stability for now. I've never had any problem with stability on Gentoo. And yeah, I think the great thing with Gentoo is that it offers a lot in terms of pedagogy. That is, when you're gonna install it, you're gonna learn a lot of things because it delves into I'd say it delves deeper into the Linux, GNU Linux structure than most distributions, because on some you just have to put a CD in the tray and let it go. No, with Gentoo you have to do basically everything yourself. You're going to have to configure you don't necessarily have, but it's good practice to configure yourself the kernel you're going to be using. And so yeah, the idea is that you're going to be able to see what's in the kernel, how it's working, what features are being supported by what part of the kernel. And so yeah, it's a great adventure. It's not necessarily easy, so you definitely need some kind of basics in Linux in general. So that's not going to be a beginner distribution, but it's a cool adventure, and I think definitely anyone using Linux at some point should try it because it's great fun. So. Yeah. Des questions. Anybody got questions?
On a français.
Hein?
Tu parles français.
I can speak English. Question en français, en anglais, comme vous voulez, si vous en avez.
Alors laisse-moi la trouver.
D'accord.
C'est la formule en fait. Ouais, quoi, il y a besoin de quoi en termes de connaissances pour attaquer Gentoo? Est-ce que je peux me mettre sur mon ordi un week-end et ressortir du week-end avec un ordi
Carrément.
fonctionnel?
En tant que, surtout que toi tu es sous Arch a priori, donc tu sais comment utiliser un terminal, ça devrait aller. Ça devrait aller. Le wiki pour ça est très bien documenté. C'est peut-être pas au niveau d'un wiki comme celui d'Arch, etc. Parce que le niveau communauté Arch est vraiment vachement grand, voilà, c'est ça. Gentoo, en fait, le truc c'est que ils ont eu un gros pic de popularité vers 2005, mais je crois qu'en 2008 il y a eu un souci avec leur wiki qui a fait que, grosso modo, ils ont perdu tout ce qu'ils avaient fait avant. Il y en a certains qui étaient un peu dégoûtés du coup parmi les contributeurs au wiki, mais le wiki de nos jours est quand même vachement bien fait. Il y a beaucoup plus de choses à voir, il y a beaucoup de choses à voir. Et globalement, surtout pour quelque chose d'aussi répandu qu'une installation de Gentoo, tu auras beaucoup de ressources de ce point de vue-là. Et tu auras beaucoup de gens sur les forums, etc., sur IRC. Voilà.
Et en termes de connaissances en programmation?
Je dirais
Nul.
Je dirais oui.
Peut-être des scripts bash quand même.
Même pas, non. Ça, c'est seulement si tu veux t'amuser avec les units OpenRC, en mode tu veux créer un service, etc. Mais ça, c'est plus des trucs que tu vas faire en tant qu'admin système, ou si tu veux bricoler, ou tu veux créer des paquets, etc. Et ça, a priori, tu auras déjà quand même besoin d'une petite base en termes de programmation.
Il se passe quoi si tu installes un paquet qui est instable?
Il se passe que la plupart du temps, il se passe rien. C'est-à-dire que tout va bien. En fait, tu as 3 types de paquets généralement. Tu as les paquets stables, qui sont supportés officiellement, etc. Tu as les paquets tildés de l'architecture, donc en fait, c'est des paquets qui ne sont pas forcément instables, en fait, et on les appelle instables, c'est juste qu'ils n'ont pas été testés en profondeur pour s'assurer qu'ils sont complètement stables. Et ensuite, tu as les paquets qui sont must, c'est-à-dire qu'en fait, ils sont genre les Gentoo, la communauté de Gentoo te recommande de ne pas les installer, sauf si tu sais vraiment ce que tu fais. C'est-à-dire qu'on sait qu'ils sont instables. C'est le cas par exemple pour certains drivers avec des cartes Wi-Fi propriétaires ou des trucs comme ça qui sont. Tu as d'anciennes versions en fait, on sait qu'elles sont buggées, et dont on sait qu'on ne peut pas y retoucher parce que c'est merde sinon. Mais voilà, globalement en fait, si tu installes un machin qui est instable entre guillemets, c'est quand même. C'est pas parce qu'en fait, c'est pas parce que c'est pas forcément assez testé pour s'assurer que ça fonctionne à fond que ça va bugger quand il y a au premier lancement. Et le plus du temps, il y a vraiment aucun souci.
Portage, et quant à ça, des paquets avec portage, genre comment tu fais si t'as pas le code source du paquet, le code source en général. Ce que je veux dire par là, c'est qu'il y a des drivers propriétaires, par exemple pour les cartes Nvidia, où t'as pas le code. Et du coup, portage, il fait comment pour l'installer en fait, vu que
voilà.
du code en fait.
C'est ça.
Bindist, les distributions binaires de paquets.
C'est ça. C'est-à-dire qu'en fait, la plupart du temps, tu compiles ce que tu peux parce que c'est du libre et que c'est mieux entre guillemets. Mais tu as aussi la possibilité de télécharger des paquets qui sont précompilés. Et donc du coup, tu n'auras pas de souci avec ça. Et c'est le cas des trucs propriétaires. Pour le coup, le build contient justement les instructions, plus ou moins ce que tu vas faire en tant qu'utilisateur quand tu veux lancer ton make, ton configurateur, etc.
Ok, portage le support du coup.
Portage le support des paquets précompilés.
Ok, d'accord.
Oui.
Est-ce que tu as toujours utilisé Gentoo?
Non, alors j'ai commencé sur... c'est un peu compliqué de commencer par Gentoo, je vais pas te cacher. J'ai commencé sous Debian il y a longtemps. Donc qui en fait c'est plus ou moins l'écosystème genre Ubuntu, c'est une version de Debian un peu plus user-friendly. Et voilà, Debian était là il y a longtemps, c'est quelque chose de... c'est vraiment une distribution core de l'environnement Linux. Ensuite je suis passé sous Arch Linux. Et vu que j'étais un abruti à l'époque, je le laissais pourrir pendant genre 1 an et donc sans l'update. Et au bout d'un moment, en fait c'est une rolling release, donc tu as intérêt en fait à appliquer les mises à jour au fur et à mesure qu'elles viennent. Parce que mettons qu'un paquet dise tiens, on va bouger tel fichier de configuration ici, mais que toi tu l'as pas fait parce que toi tu sautes 3 versions et la version dans laquelle tu arrives après en fait, pour eux le fichier de configuration a déjà été bougé. Du coup, tu vas avoir un souci, et c'est comme ça qu'a craché mon arche, et j'ai juste eu le flemme de la remettre en place en fait. Du coup, je suis passé à Gentoo. Oui, je suis le genre de mec qui se dit qu'il a la flemme de réparer son arche et qui passe un week-end entier à installer Gentoo.
C'est normal.
C'est normal. Voilà. Ça répond à ta question?
Alors, du coup, j'ai une question de te mettre.
Ouais.
cuisse ou arche.
Ouais.
Arche, non, concrètement, au niveau des repositories utilisateurs,
Ouais.
est-ce que tu as eu des difficultés comme on peut l'avoir sur OR, où des fois des paquets ne sont pas forcément maintenus correctement, et donc tu vas avoir quelques logiciels que tu vas vouloir installer qui vont bizarrement juste pas marcher, il y a la possibilité de les supprimer?
Alors, personnellement non. Après, c'est forcément un risque parce que du coup, les overlays sont maintenus par la communauté et tu peux avoir des overlays qui sont laissés à l'abandon pendant 5 ans. Enfin, voilà. Après, c'est. Je dirais que le truc par rapport à OR, c'est que les overlays en question sont pas forcément référencés comme ils le sont, comme les paquets sont référencés dans OR, où bah, tu vas juste sur OR, tu cherches ton paquet, tu installes, etc. Mais c'est aussi, enfin, il y a deux manières de voir la chose parce que du coup, ça te permet de, comment dire ça. Les overlays, souvent, c'est des groupes de paquets au lieu d'être des paquets individuels. Ce qui fait qu'en fait, pour les machins qui sont plus utilisés, par exemple en sécurité informatique, par exemple dans le domaine particulier, vu que c'est des groupes de paquets, il va y avoir des plus grosses communautés, ce qui fait qu'en fait, il y aura plus de contributeurs sur ce groupe de paquets-là qui vont maintenir les choses à jour par rapport au paquet de la manière qu'ils ont dans les autres distributions. Ce qui fait qu'au final, tu n'auras pas trop de soucis souvent avec tes paquets, vraiment, sauf si tu tombes sur un machin qui est vraiment particulier. Je sais qu'il y en a aussi sur OR, mais voilà.
Est-ce que tu peux maintenir un parc de machines sous Gentoo sans que ce soit chronophage?
Bah alors,
genre j'ai 7 machines, dont un serveur, une tour pour le jeu et mon laptop de travail.
Honnêtement, je pense.
Tu penses que c'est faisable ou tu penses que c'est faisable facilement?
Je pense que ça passerait déjà par l'installation d'un serveur de cache / compilation, parce que clairement, t'as pas que ça faute de compiler tes paquets sur cette machine à chaque fois. Après, je pense que c'est faisable. Je connais quelqu'un en fait qui, c'est plus ou moins lui qui m'a introduit à Gentoo en fait, et qui sur ses serveurs de prod par exemple tourne sous Gentoo. C'est assez rare pour être remarqué d'ailleurs parce qu'une rolling release sur un serveur de prod, souvent c'est un peu antithétique. Et pareil, il n'y a jamais eu de problème. D'un point de vue stabilité, c'est quand même assez impec. Après, faire ça facilement, je dirais facilement à l'échelle de Gentoo, c'est-à-dire que ça te demande quand même un. Voilà. C'est-à-dire que, a priori, si tu sais setup une machine, tu sais en setup 7. Après, tu peux aussi faire. Ça dépend de la config de ta machine. Si y a 7 configs différentes aussi, ça va être un peu plus conseillé à maintenir que cette machine avec une config identique. Je pense que par exemple, dans le cadre d'un établissement, genre une école ou un truc comme ça, si tous tes PC ont la même config, ça doit se faire plutôt facilement. Après, cette config différente, le fait qu'en fait ce soit quelque chose de plus spécialisé, que tu n'aies pas un kernel qui soit général comme dans tous les autres distros, ça fait que tu auras du coup à chercher, à customiser le truc plus ou moins selon chaque machine. Ou alors à utiliser le kernel, parce que ça c'est un truc dont je peux parler. Quand tu configures ton kernel, en fait, tu as deux manières de le faire. Tu peux soit le faire à la main, donc make menu config, tu sélectionnes des options, etc. C'est un peu chronophage, c'est pédagogique, tout ça. Mais tu as aussi Kernel qui est un utilitaire, grosso modo, qui te permet de configurer ton kernel et qui fait de la détection hardware par rapport à ce qu'il y a sur ton PC. C'est-à-dire que souvent, tu le fais tourner sur un live, un truc comme ça, donc tous les drivers sont là, tous les périphériques sont inconnus. Il tourne, il voit ce qui est sur ta machine et il configure plus ou moins le kernel de manière généreuse, parce que faut que ça marche, au bout d'un moment. De manière généreuse, et du coup, tu as un kernel qui n'est pas forcément très optimal, mais qui est quand même assez adapté à ta machine et qui fonctionne. Voilà. Donc c'est une autre manière de voir les choses. Oui.
Dernière petite question par rapport à Slackware.
Ouais.
Est-ce que tu as pu tester Slackware et si oui, quel est ton avis?
J'ai pas pu tester Slackware. Je sais qu'en termes de taille, une image Slackware ça pèse quoi, 200 mégas, 300 mégas, non?
C'est à peu près similaire à Gentoo au niveau.
Ouais, voilà. Donc je peux pas tester Slackware, en dehors de ça je peux pas te dire. Je sais qu'en termes de taille c'est très très similaire. Ouais, après. Ok. Alors il y a un vent.
Quand le serveur qui compile tes paquets en fait?
Quand j'aurai comme monté un NAS, parce que j'aimerais monter un NAS avec, qui me permet de sauvegarder mes données, etc. avec un port 6 et tout. Et donc du coup je pense qu'on servir comme serveur de compilation aussi.
Tu vois, on a des machines en RAM à la cave.
Parce qu'il a déjà trouvé des disques de 500 Go alors.
Pas les disques.
Pardon.
Parce que juste, actuellement, combien de fois, quels sont les temps où tu fais des mises à jour de compléter ton système en fait? Parce que ça doit être très espacé parce que tu les compiles sur ta machine, tu as un peu la flemme de faire tous les jours des mises à jour de tes paquets, je suppose.
Oui et non, dans le sens où quand tu fais une mise à jour par semaine, tu as 3 paquets à mettre à jour. Quand tu fais une par mois, tu en as 150 à compiler. Du coup, souvent, tu as plus intérêt à faire ça régulièrement que longtemps, parce que ça prend beaucoup moins de temps, et puis franchement, tu le laisses tourner de nuit, et puis voilà.
Tu fais une mise à jour complète par semaine et tu arrives à
C'est
tenir
ça.
le rythme.
C'est ça. Parce que le rythme des paquets, simplement, genre, pas tous les paquets qui vont se mettre à jour tous les 3 jours.
Oui, bien sûr.
Donc sous Gentoo, 3 x 4 égale 150.
C'est l'idée. L'idée, disons.
Entendu, c'est un fork de quel stream?
Gentoo,
Ouais.
c'est standalone, c'est pas un fork.
Mais du coup, est-ce que du coup les applications elles sont organisées plutôt comme sous un Debian ou un Arch un peu en bordel ou plutôt comme un BSD vraiment tout rangé?
Alors, c'est marrant que tu parles de BSD, en fait, le nom de portage, ça vient plus ou moins des ports BSD. Alors j'ai lu ça, honnêtement, j'ai jamais utilisé BSD, donc je peux pas te dire à quoi ça correspond. En revanche, voilà, c'était quoi la question déjà? Bon. Je me suis perdu dans mes pensées.
T'as parlé de quoi?
Ah, la question, est-ce
Oui.
que c'est les paquets, tu sais, quand tu les installes, ils sont organisés de manière très organisée comme BSD où c'est vraiment, tu sais, t'as un répertoire et ça doit être là et pas ailleurs?
Plus ou moins, dans l'idée, plus ou moins oui. C'est-à-dire que tu as vraiment le repository officiel Gentoo, où vraiment tu as tous les paquets qui sont vettés par la communauté, tu as pas mal de vetting à chaque contribution. Et puis tu as tout ce qui est overlay, etc. Mais ouais, dans l'idée, c'est ce qui est officiel, c'est organisé, en tout cas.
Du coup, quand elle est faite,
Bientôt, d'ici l'année prochaine. Charles.
Il y a Thibaut qui demande ce que tu peux dire à la caméra. By the way, I'm using Gentoo.
De quoi? Ah, by the way, I'm using Gentoo.
Merci.